So students, today we are going to discuss about this structural mitigation part of for the particular disaster, and that is called as disaster safe construction and design. So basically this disaster safe design and construction, that is more or less related to your structural mitigation aspect. So for different disaster, we will be seeing which kind of design and construction and which kind of provisions that can be adopted to make it disaster proof or disaster safe. So here in this building, this earthquake proof resistance or the earthquake resistant building, which kind of concept and which kind of principles that can be applied, that are given in this two figure. Because most of the time this earthquake proof resistant, that is very essential for making it disaster proof, because most of the construction aspect that is related to make it disaster earthquake proof building. So first we'll talk about this earthquake only. Okay, if you want to make your house or if you want to make certain building which should be earthquake proof, then which kind of provisions that are given in the guideline that we want to see. Okay, so here starting with some of the aspect why it is essential in India. So first we should know about this seismic zoning. So basically India is having very unique geophysical setting, and which is highly prone to earthquake of varying intensities, and several devastating earthquake in the past that has resulted in large number of deaths and severe property damage. So during last century, the data says that five earthquake measuring magnitude about eight magnitude ke earthquake, they have struck a different part of country, right from this Great Assam earthquake, then this Kangra earthquake, Bihar Nepal earthquake, Andaman Nicobar earthquake, and Assam earthquake. And in Gujarat also, we have observed one of the major devastating earthquake, that is in Bhuj earthquake, that was in 2001. The magnitude was 6.9. Though its magnitude was around 6.9, though we have seen how much devastation that has taken place due to that earthquake. And if the construction, the most of the construction that has collapsed, okay, and if a proper earthquake resistant building that is not constructed in such earthquake prone region, then how it can result in loss of life and loss of property. So basically India, that it is classified into different seismic zone, and these zones, it gives the intensity of damage or frequency of earthquake, कितने टाइम पे आ सकता है and कितना डैमेज हो सकता है. Accordingly these zones are divided, and these zoning maps indicate broadly the seismic coefficient, and this seismic coefficient that can be adopted for the design of building in different part of country. So this seismic zonation is very important, and that will guide particular contractor how to design a particular earthquake resistant structure. So these maps are based on the subjective estimate of intensity from available information or the on the earthquake occurrence. So all the earthquake which are occurring in India, that are generally measured, and in the from the database, that whatever intensity, and that data of earthquake occurrence regarding the intensity, that data is very useful to you in making such maps, and geology and tectonics of the country. So this Indian seismic zoning is a continuous process, and which keeps undergoing changes as more and more data on the occurrence of the earthquake becomes available. So this IMD is the nodal agency for this measuring and preparing such a seismic zonation in India. So here, this data which is available from the NIDM, this source I have taken. Here it is the seismic zonation map of India of 2002. So here, looking to this zonation, India is divided into four different zones: Zone 2, Zone 3, Zone 4, and Zone 5. So this intensity of the earthquake in zone 5, that is red zone, it is having very high risk area. So this area, they are liable to shake with the intensity of around 9 and above. So you can say it's a very high risk zone. So here this red marking that shows the high risk zone area. So it should be compulsory that all these area, they should have earthquake resistant structure compulsorily by enforcement, by legal framework. Next zone is zone 4. So it is considered to be a high risk zone, and that may feel the intensity around 8. So this zone 4, this is the area that is orange zone, that here you can see the whole Himalayan range. Okay, that is not very, that is a high risk zone. Around intensity can be felt around 8. Then zone 3, so the zone 3 is moderate risk zone. So we are living here in Gujarat, most of the part that is moderate risk zone. That intensity is around 7. And zone 2, that is considered to be low risk zone. So here the intensity may be around 6 and lower. Okay, so this particular seismic zonation, it indicates that about 59% of the land area of India, it is liable to seismic hazard damage. Okay, and due to that, it becomes very essential that in particular those area which are very at a high risk zone or very high risk zone, there should be constructed so that it should be earthquake proof. So it is seen from this particular zonation, seismic zonation, Guwahati and Srinagar. They are located in zone 5. Okay, so on an average, you can say 11% of the area it is under zone 5. 17.49% area it is under zone 4. Zone 3 it is 30.79, and 40% around area that is under zone 2. तो लो रिस्क तो अपना मतलब जोन 2 में तो 40.1 40.9 जितना है, but most of the 59% area that is under moderate to high risk zone. So it is very essential that the structure should be earthquake proof. Delhi is in zone 4. Mumbai, Kolkata, Chennai, they are in zone 3. So it is observed that 38 cities with a population of half a million and above, and a combined population of million are located in these three zones. So it is very essential that disaster proof constructions are to be made mandatory in such particular uh, risky zone as far as earthquake is concerned. So this particular seismic zonation, it will give you idea in which zone as far as the earthquake risk is considered. Okay, so here these are the region wise major earthquake in India. So you can see that northeast India, it is more vulnerable as far as all the uh, earthquake magnitudes are concerned. Most of the time the frequency you can see. Okay, so 8 and above it is 4. So here this return period of the earthquake in this particular area, that is less than 4 months, that is observed. Okay, so this kind of studies that can be very useful in and that can guide that which area it should be mandatory to go for the earthquake proof construction. So here this National Institute of Disaster Management, NIDM, they have given guideline for designing that safe house in the earthquake prone region. So, as far as this earthquake prone settlement or earthquake prone planning is concerned, then local planning authority, they should assess the project based on this following guidelines. So this guideline says that location and extent of seismic hazard zone, epicenter, faults and fault system, they should be first ascertained. कि उसका लोकेशन पता होना चाहिए, उसका एक्सटेंट पता होना चाहिए कि कौन से हैजार्ड जोन में है, एपिसेंटर कहाँ पे आ सकता है, फॉल्ट एंड फोल्ड सिस्टम that is to be established. Then magnitude and intensity of the earthquake in that particular area. कोई भी प्रोजेक्ट को आप फाइनलाइज करने से पहले यू हैव टू चेक दिस. ओके, other geological hydrological features influencing the ground shaking and deformation apart from earthquake, which are the other hazards which are possible in that particular region. Then potential secondary hazard. So secondary hazard क्या हो सकता है, secondary effect क्या हो सकता है, that should be ascertained. And next is the frequency of event, कितने अंतराल के बाद वो वापस आता है. So this vulnerability assessment will be based on zoning and micro zoning. So this zoning and micro zoning is very important. Then maps of seismic source, that is related to faults and fault zones. Then geological and geomorphological map and survey, these are to be used. Then data of post occurrence of earthquake and its effect, कि earthquake के बाद भी उसका क्या effect होता है, that is also to be ascertained, and calculation of maximum ground acceleration कितना हो सकता है, and liquefaction. Basically this liquefaction is strength and stiffness of a soil that may be reduced by the earthquake shaking. So if some frequency is large, so which kind of liquefaction susceptibility is there in that particular region, that is to be ascertained. Okay, so these are some of the guidelines given by an idea. Now we'll talk about the design considerations for the earthquake resistant structure. So very important thing is site selection. सबसे पहले site कहाँ पे select करना है if you want to make your house or make any building that earthquake proof. So first it should be away from fault lines. This is very essential requirement. Site to be chosen with the help of GIS seismic mapping. हमको हमारे पास seismic mapping है. Accordingly, whatever fault line are there, then it should be away from that and mainly concerned with the stability of slope. So you cannot construct any major project on the active fault line in which anytime earthquake may come up. So it should be away from the fault line. Then stability of slope. Generally in the hilly region, on the slope, you may see many buildings. Okay, so if they are not stable, that then they are more liable to be damaged during earthquake. So this hill side slopes, they are liable to slide during earthquake. पूरे slide हो जाएंगे, and it should be avoided, and only stable slopes that they should be chosen to locate the building. So in the hilly region also, they should try to find out the stable slope. So whenever there is a ground shaking, they should remain in stable condition. Okay, so the stability of slope is very essential parameter. Next is a site subjected to danger of rockfall. Okay, so this is also particularly landslide occurs, some rockfall may be there. So if it's a landslide prone region, some rockfall, if you know that some rockfall may be there, so it should be away from that. And avoid very loose sand or sensitive clay, because this foundation is very important. So both the types of soil, अगर loose sand है या sensitive clay है, these two types of soils are more liable to be destroyed by the earthquake. Okay, because they lose their original structure, and this will result in large unequal settlement. एक part आपका मतलब unequal settlement हो जाएगा, ठीक है, एक part अंदर चला जाएगा जमीन में, दूसरा ऊपर हो जाएगा. So that will result in unequal settlement and it will damage the building. And if loose cohesionless soil means example is sand. If they are saturated with water, sand के अगर अंदर पानी आ जाता है, they will lose their shear resistance and altogether during shaking and become liquefied. So they cannot take the load of whatever structure. Okay, so this kind of soil should be avoided. Although such soil can be compacted, आप उसको compact कर सकते हो for the small building operation, and they may be too costly. So it's better to avoid in the earthquake prone region such kind of soil. And for large building complexes such as a housing development, a new town, these factors should be investigated thoroughly and appropriate action should be taken. You should not allow any project to build on such kind of soil. A site with a sufficient bearing capacity. Bearing capacity means it should take whatever load for which it is designed. So if that soil or foundation, they should not have that proper bearing capacity, then it should not be chosen for the site of that project. And also this drainage condition, it should be improved so that no water can accumulate in your foundation level. Foundation में पानी ना चला जाए. So these are some of the points that are to be observed while selecting site for the earthquake prone region if you are going for the construction. So here these are general principles for the earthquake resistant design that you should understand. So first, structure should not be brittle. तुरंत टूट जाए ऐसा structure नहीं होना चाहिए. So it should not be brittle or it should not collapse suddenly. Suddenly अगर टूट जाते हैं तो वो आपको warning नहीं देता है. So rather it should be tough and able to deflect or deform a considerable amount. Means टूटने से पहले आपको वो वार्निंग दे, ऐसा स्ट्रक्चर होना चाहिए, तुरंत नहीं टूट जाना चाहिए. सो इफ इट गिव्स यू वार्निंग, some cracks are developed and it will take some time to collapse. It should not suddenly collapse. So that is the first requirement. This resisting elements such as bracing or shear wall must be provided. So here in this figure you can see this kind of bracing wall. Cross bracings are provided, and that are generally the reinforced wall. Means steel के bars use किए जाते हैं to make them cross bracing. Also this shear walls. So here you can see this is the shear wall. So this should be provided in both the directions, side to side as well as from top to bottom, so that can resist such forces. So all elements such as wall and the roof, it should be tied together. So जो भी आपका पूरा element है, it should be properly tied, and it should act as an integrated unit during the earthquake shaking, and transferring the forces across the connections and preventing the separation. So it should not be separated at the time of shaking. So they should act as a integrated unit, not a separate unit के सब separate हो जाए. ठीक है. So this RCC shear wall, then this cross bracing, this that are to be adopted. Also now a new concept of shock absorber. So here at the base, at the foundation level, some shock absorber that are generally called as the base isolator, so that will absorb the tremors of the earthquake. So that kind of things can be adopted. And the building must be well connected to your foundation. जो भी आपका foundation है उसके साथ वो well connect होना चाहिए. Also this wet and soft soil, it should be avoided. Foundation में ये सब soil नहीं होनी चाहिए. Okay. And where this soft soil cannot be avoided, the special strengthening mechanism should be adopted. So these are just some of the general principles for any earthquake resistant design. Also the care should be taken that all the materials that we have used, that is of good quality, and should be protected from all other elements that will make them weak, like protection against rain, sun, insect. Okay. Then unreinforced means जिसमें हमने steel bars use नहीं किए हैं, so that are unreinforced earth or masonry जो भी हम use कर रहे हैं, that are they have no reliable strength in tension, and they are also brittle in compression. So generally they should be avoided. It should be properly reinforced, means proper steel bar arrangement should be provided. So basically the categories of the building, they are this categorization of the building with the purpose of achieving seismic resistance to a economical cost. Three parameters are generally chosen. कौन सी बिल्डिंग को किस टाइप का हम प्रोटेक्शन प्रोवाइड कर सकते हैं. सो फर्स्ट इज सेस्मिक इंटेंसिटी जोन where the building is located. So that is very important कि कौन से जोन में located है. Second, how important building is, कितने लेवल का प्रोटेक्शन उसको चाहिए. Okay. So whether it is a lifeline kind of building, hospitals, etc., or whether it's a simple building, kitna hai. So how important is building? How stiff is the foundation soil? So this foundation soil जिस पे हम हमारा structure रखने जा रहे हैं, so kitna stiff है. So these are the factors that will be useful in categorizing the building as far as the seismic resistance is concerned. And combination of these parameters will determine the extent of appropriate seismic strengthening for any building. Okay. So here certain general planning and design aspect that in a simple word I will discuss with you. So first is plan of building. So whenever you are designing plan of your building, some symmetry should be there. So here you can see two figures here, 1 and 2. So this first one, it is asymmetrical plan. Plan में देखेंगे आप asymmetrical है. While here this is a symmetrical plan. Okay. So building as a whole, it should or with various blocks, it should be kept symmetrical about it both axes, x and y axis. यहाँ पे आप देखोगे x and y both axes it is asymmetrical, while here it is on x and y axis both it is symmetrical building. Okay. So this asymmetry leads to torsion. So if such kind of building which is asymmetrical, so here it's whenever there is a earthquake force is there, then it will twist or due to this torsion during the earthquake, and it will become dangerous. So here this T, it represents torsion of an asymmetrical plan. So less effect is observed in such symmetrical building. And this symmetry is also desirable in placing and sizing of doors, window openings. So here you can see these doors and window openings that are also in symmetry. So this kind of symmetrical plan, it will give you better resistant. It is better resistant to earthquake as compared to asymmetrical planning, due to because the center of stiffness and center of gravity, that is properly maintained in this particular symmetrical plan. So as far as possible, the plan of the building, which should be symmetrical on both the axes to be earthquake resistant. Next is regularity. So what do you mean by this regularity principle? Simple rectangular shape should be adopted. So simple rectangular shape will behave better in earthquake than the shape with many projections. Okay, so here I will show you in this figure. Here this is a symmetrical desirable plan. So here this is simple square, this is rectangular. So all whatever this A, that is this particular buildings that are having very symmetrical desirable plan. Okay, rectangular. And while here in second there are long and undesirable plans. So here this length, it is greater than 3 times width. Okay, here some offset is there. Here symmetry is there, but I section with the long projections are there. So here this is U-shaped building. So as far as possible, this type of structure should not be adopted for if you want to make your building earthquake resistant. So this torsion effect of the ground motion are pronounced in long, narrow rectangular block. And if it is desirable that to restrict the length of the block to 3 times of width. So length should not be greater than 3 times of your width. Okay, and if it is desirable to have a longer length, then two separate blocks can be considered with the sufficient separation between them. So if still you want that कि आपके पास बहुत सारा लेंथ है, आपके पास जमीन ही ऐसा है कि आपके पास बहुत सारा लेंथ है, so instead of going for a long block, you can make them separated, that is length having less than 3 times its width. So means you can separate your blocks. Okay, and this separation of the block that is provided with certain sufficient distance with them, एकदम कम distance भी नहीं होना चाहिए. Okay, so this separation of the block of a large building into several block may be required so as to obtain the symmetry and regularity of each block. तो सब block में आप regularity symmetry ला सकते हैं. So for preventing the hammering or pounding effect is whenever there is a earthquake shaking, the collision amongst the adjacent building may be there. So if you are doing separation, if distance is very less, so in that case that pounding effect may be observed. So both the building block they will call it with each other, एक दूसरे के साथ टकरा जाएंगे. So this physical separation of the block, it should be 3 to 4 centimeter minimum throughout the height above the floor level. It should be adequate. So in practical you can say that up to 3-story building, 3 माले का जितना building होता है उसमें minimum 3 to 4 centimeter physical separation should be provided throughout the height above your floor level, that is called as the plinth level. And this separation section can be treated just like a expansion joint कि expand हो रहा है, ठीक है. And it may be filled with the some weaker material that can be easily crushed and crumble during the earthquake shaking. So whatever separation part is there, it should be filled with certain weaker material जो crush and crumble हो जाएगा at the time of the particular shaking. So such separation may be considered in large building. Okay, and it may not be convenient in the smaller building. So here all these blocks here, instead of having this one single block, you can have 3 blocks. Okay, and all this with proper separation, minimum 3 to 4 centimeter amongst them. So all these building blocks that are showing unsymmetrical, that can be converted into separated block by this kind of separation arrangement. So this should be separation about 1 centimeter per story height. So minimum 3 centimeter for up to 3-story height may be provided. So by using such separation block, you can bring symmetry and regularity to your building and make them earthquake resistant structure. Next is simplicity. So whatever that ornamentation और जो भी हम डेकोरेशन करते हैं, कुछ बाहर प्रोजेक्शन निकालते हैं, so that ornamentation that is involving large cornices, vertical or horizontal projections, that such kind of stone cladding, fascia stone जिसको बोलते हैं, they are dangerous and undesirable from a seismic point of view, because if they are not properly secured with your building, then they may come out and that will fall down. Okay, so simplicity is the best approach for any earthquake resistant structure. So here this is the simple plan of building. So this is good plan as far as earthquake resistant structure is concerned. Here you can see this corners and curves that are provided in the plan of the building. So that will bring unsymmetry as well as against simplicity. So that are not good. Also this separation joint makes more complex plan into simpler plan. So this separation that can be avoided, that can be adopted. So when ornamentation is insisted upon, it must be reinforced with the steel. So steel reinforcement is essential when such kind of ornamentation it becomes necessary, and it should be properly embedded or tied together with the main structure. So properly tie up of such ornamentation is necessary. So generally in design, a seismic coefficient of about 5 times the coefficient used for designing the main structure, it should be adopted for the cantilever. Means projection जो भी आपने किया है उसका 5 times coefficient consider करना है as compared to main structure. Next is enclosed area. So here a small building enclosure with properly interconnected wall act like a rigid box. वो rigid box की तरह काम करेगा. Okay. So therefore structurally it will be advisable to have the separately enclosed room rather than a one long room. Okay. So some separation. So this is not good. Okay, no cross wall large box, it is seismically weak. So instead of that you can have many cross wall small boxes. So here you can see small boxes, it is converted into small boxes, so which is seismically strong, and here it is provided with the structural framing element. So beams etc provide करेंगे, collar beam, then so this is collar beam, this is column, it is properly connected with the foundation. So for unframed walls of thickness T, अगर आपका thickness of wall is T है, and A is the wall spacing, so this is the spacing between wall if it is A, and T is the thickness of wall. So ratio of A upon T should be 40, and it should be provided with the proper cross wall, and large panels or thinner wall that are provided with the proper framing elements. So this structural framing in general it should be of two types. So for the framed construction, it should be a light framing members, certain having some diagonal bracing can be adopted, or substantial rigid joint with the help of, already I have discussed this, columns, beams, proper foundation, or certain kind of the in between cross wall that can be very useful to make your structure seismically strong. So both ways, this kind of arrangement by the light framing member or substantial rigid framing that can be adopted for your enclosed spacing to make them more seismically strong as compared to such kind of box which is having more length, no cross wall, and it's a larger block. So that is a seismically weak kind of structure. So this should not be adopted. So generally, whenever we are dealing with earthquake resistant structure, these three concepts are to be followed. First desirable properties of the earthquake resistant structure is ductility. Means वापस अपनी original position में आ जाना. It should be ductile. Deformability and damageability. So ductility and deformability, they are interconnected, interrelated concepts signifying the ability of structure to sustain large deformation without collapse. मतलब collapse हो उससे पहले उसमें deformation आए, but it will take time to collapse. So तुरंत on the spot sudden collapse should not be there. Okay. So damageability refers to the ability of structure to undergo substantial damage without partial or total damage. Okay. So deformation थोड़ा damage होगा लेकिन without partial or total collapse. Total collapse होने से पहले that will warn you so that at least you can save your lives. So this is desirable because it means that a structure can absorb more damage, and because it permits the deformation to be observed. So at least you can observe the deformation कि भाई यहाँ पे crack हो गया है, यहाँ पे ये हो रहा है. So we can leave that particular area. So repairs or evacuation to proceed prior to collapse. So at least you can repair them or you can evacuate if it is emergency. So this sense of warning that is received and lives can be saved. Okay. So these three aspects are very important whenever we are designing for earthquake resistant structure. Now there is a recent concept which is called as the concept of isolation. Isolate कर देना, ठीक है? So it is a measure to isolate the structure. जो आपका complete ये structure है, basically it is connected with the foundation. Okay, so if it is rigidly connected, whenever there is a earthquake, it will move like this completely. Okay, but when you will isolate your structure, this structure, विद द बेस, यहाँ पे बेस पे फाउंडेशन है, उसके बीच में आपने कुछ बेस आइसोलेशन बेरिंग्स प्रोवाइड कर दिए, इट आर शॉक एब्जॉर्बर. Okay, so only at the time of ground shaking they will move like this, and the whole structure can be protected. Okay, यहाँ पे तो पूरा स्ट्रक्चर टेढ़ा हो गया, तो यहाँ पे ऐसा नहीं होगा. So base isolation is also known as the seismic base isolation, and one of the popular means for of protecting this structure against the earthquake forces. So the base of the building provided with the base isolators, पूरा isolate कर देना है base को, to keep the structure steady during earthquake, and their ductility behavior absorb the energy. Okay, so it's a ductile in nature. So it involves the constructing a building on a flexible pad which is made of steel, rubber or lead. And when base moves during the earthquake, ये base ही खाली move होगा आपका, only this base will move, and the isolator vibrate while the structure itself remains steady. So this kind of base isolators that are generally provided to isolate your building from your foundation, and this effectively helps to absorb the seismic waves and prevent them from traveling through a building through the high damping properties that these isolators have. So basically, in the simple building, base friction isolation may be achieved by reducing the coefficient of friction between the structure and its foundation by placing the flexible connection. तो कोई flexible connection अगर आप base में provide कर देते हो, so that will protect your whole building. So here, just see this in this building, this kind of base isolators that are provided. So here, this is the building without base isolation. So here you can say during earthquake, it will sway fast and intensely. While in case of this particular building that is provided with the seismic isolation construction, it will sway slowly and moderately. And particularly, this will move fast, and this will protect your upper part of the building. So basically, the principle of base isolation system is like base isolation system or suspension system, which is provided in your motor car, which is provided with the soft spring and oil damper. Okay, so this kind of base isolators in the form of laminated rubber rings that can be provided at the base of the building, so that will absorb the shock. Okay, so here so few figures are there that will show you how this base isolators can be provided to isolate your building from the foundation. So this basement column, they are supporting the base isolator. So this base isolator, they can be very useful at the time of earthquake. Okay, and they will move, and that will save your upper part of the building. So these are the different types of dampers which can be used at the base of the building. And this is the internal arrangement, how they are uh, responsible for absorb the shocks and vibrations during earthquake. So these are some of the elements that already I have discussed. So just as a summary, I have put in the form of the figure. So this is the conventional structure. So severe shaking is observed, while in case of the seismic isolation, balanced and moderate shaking is observed, and most of the time this will move and this will protect your structure. So this kind of cross bracing that is generally provided. Also here you can see this is column and this is beam. So this kind of structure is better. Strong column with weak beam design, so that is okay, because these columns are responsible to transfer the load. But this kind of structure is not at all allowed कि जिसमें आपने बहुत ही मोटे, that is strong beams are provided and weaker columns are provided. So this is not desirable structure. So this cross bracing, then shock absorbers, and this shear wall construction, all are necessary features of any earthquake resistant building, and that are generally adopted to make them earthquake resistant building. So this is one of the example of base isolation building. This is the research building. These are some of the features that are shown, that is located in Tokyo. Okay, that is provided with the base isolator. So you can just see this, how much big base isolation device that is provided just to isolate that the building from particularly foundation, because this Japan, it is having a high risk zone. Okay, and every day you can say the earthquake is coming, so they need to construct earthquake resistant structure. So these are the list of the Indian standards which are dealing with the earthquake resistant construction. So these are all the list that are very useful for the civil engineers if they want to design particular building that is earthquake resistant, and this is given by NIDM. So these are all the series IS 1893 part 1 2002, then 2005, and these are all different IS codes that are generally followed. Okay, so this is earthquake resistant design and construction of building code of practice. So these are all the guidelines that are given by NIDM to construct any building in a earthquake prone region. Okay, and these criteria that are to be followed if any construction is to be done in a particular area which is earthquake prone region. So there is a need to strict monitoring of the modifications of the building, recognizing seismic risk and vulnerability. Strictness is very important. No relaxation in building plans which violate the safety parameters in relation to the earthquake safety will be permissible under any law, rule or regulation. So strict enforcement, whatever provisions that are given, that is to be strictly followed. It is essential. And while revising the development control regulations, if revise कर रहे हैं, a master plan and special attention should be paid to ensure that seismic risk and vulnerability of existing building to withstand the high intensity earthquake before allowing any relaxation relating to approval of additional floor. So जब भी addition of any floor that is to be allowed, then this kind of provision they should be strictly checked. And without what you can say differing from whatever provisions are given, the permission should be given to them. So strict provisions whatever given as per the law and given by NIDM guideline as per our IS code that are to be strictly followed in the earthquake prone region to make them earthquake resistant structure. So thank you very much. We have discussed all the basic aspect and principles that are essential for earthquake resistant structure and which is to be made compulsory. It is compulsory for the earthquake prone region to make them disaster safe as far as earthquake is concerned. Thank you very much.